Okay, so this is the review of the third inheritance lab, the one for abstract classes. So what we're given here is we're given uh, a shape class. The shape class has public double area, which just returns -1, public double perimeter, which just returns -1, and semi-perimeter, which returns the perimeter divided by 2. And then we're also given this shape tester program that has a main that makes a shape, it makes a circle, it makes a rectangle. We've got errors right now because we have not yet made the circle and rectangle classes. So let's come back to this shape. And the first thing that we're asked to do is to create a subclass of shape called circle. So file, new, sorry about that, file, new class. And this is going to be called circle. Okay. Now we're going to say that circle extends shape. And a couple things that we need to have. It needs to have a variable called radius. And it needs to have an area and perimeter method that uses the appropriate formulas, and it needs to have a constructor that takes a double value for the radius. Now, remembering that shape has no variables, then we don't have to worry about calling super to make it a shape. So we can just kind of come in here and we do public circle radius, and we say this dot radius equals radius. And we're just assuming that everyone is giving us um, valuable or valid information. All right, so I also need to override now public double area and public double perimeter. So public double area is going to return 2 pi r. I'm sorry, pi r squared. So it's math dot pi times math dot pal radius to the second power, and public double perimeter is going to return 2 pi r. So 2 times math dot pi times radius. Okay. So that's our first task. And then we've got another class we have to create called rectangle. And so we'll come out here and we'll make rectangle. Again, rectangle is going to extend shape, and it needs to have private double length and width, and a constructor public rectangle uh, double length, double width, and this dot length equals length, and this dot width equals width. And again, public double area, turn length times width, and public double perimeter, turn 2 times length plus 2 times width. Okay, so there we go. Now we've created our subclasses of shape and circle. Sorry, rectangle and circle. And if we come back to shape tester now, we don't have any errors anymore. So we're going to give this a run. And you'll see that the first thing that I have is a shape with an area of -1. The shape has a perimeter of -1 and a semi-perimeter of -0.5. Here's the area of the circle, the perimeter of the area of the circle, the semi-perimeter of the circle, and then the same here for the rectangle area, the rectangle perimeter, and the rectangle semi-perimeter. Now, as we sit here and we talk about the concept that of a shape, and we talk about finding the area of a shape and the perimeter of a shape, well, we know that the area of it, let's come back and look at shape. We know that the area of a shape is the space inside of a shape. And we know that the perimeter of the shape is the measure of the outside of the shape. But it doesn't really make sense um, that we're trying to find the area and the perimeter of a generic shape, especially when we talk about mathematics and geometry and those kinds of things. This concept of shape is an abstract concept to us. And so one of the things that we can do here is we can declare this as an abstract class. So we declare shape as abstract, and you're going to see once I make this change, now I'm going to get an error. And the error that I'm going to have here is that when you have an abstract class, when you have a class that is declared as abstract, you cannot instantiate it. Notice that I can declare it, but I cannot instantiate it. So this is kind of out the window right now. I'm not allowed to have that. So then I'll just come down here and I'm going to declare this as shape. So all the rules of our inheritance from before still take precedence. I can instantiate a subclass into a superclass should I choose to. Um, the other thing that happens back here is that it doesn't really make sense, as we were saying, to find the area of a shape or to find the perimeter of a shape. So really, these should be declared as what we call abstract methods. Abstract methods do not have any kind of body or implementation. And therefore, we write public abstract double area, public abstract double perimeter, and we just write a semicolon and that's it. Now, semi-perimeter still works because if we find the perimeter of an object, then we can find its semi-perimeter, so we don't have to rewrite that every time. We can actually benefit from this inheritance. Um, but finding the area and the perimeter of a shape generically just doesn't make sense. So the nice thing now is that when I use circle and circle extends shape, um, I've got these two methods here, and when it goes to look for semi-perimeter, um, it doesn't find it. So it goes up the chain to shape and finds a semi-perimeter method. And the semi-perimeter method calls the perimeter method, but it calls the most local version of the perimeter method, which is the circles perimeter method. And so this is actually, I'm going to come back here and save that, and we'll run that again. And so actually everything over here still works for us. Um, so that's what's happening here as we go through and we start to declare these methods abstract and we declare this class as abstract, is that we can then come down and we have to implement those methods. So we're just kind of making a contract here that says, all right, look, if this is going to be abstract, then when you implement it in a subclass, you have to implement those methods to make the subclass concrete or not abstract. And so there is the answer to our problems. So thanks.